Welcome to yet another session of the course, The Joy of Computing Using Python. So, these are live problem solving sessions which are conducted every week, every Saturday from 3 to 5 p.m. The aim of these live problem solving sessions is to solve questions from previous year's assignments so that they help you in gaining confidence for the concepts that you have studied this week, and also they will help you in solving the current session's assignment problems. So every week we look at a few MCQ type questions as well as programming type questions. So this is for week 9, and in week 9 we have learned some new things like networks. So the aim of the assignment problems is largely based on solving questions from the networks package. And also so every time you have some programming assignment type questions, you will also be utilizing concepts learned from the previous week. So it's not as if that you have learned something from the previous weeks and then you have to forget it. That's not how programming works. You build upon the concepts slowly and week by week. So yeah, so let's get started, and we will look at questions on networks, on author stylometry, NLTK package, um, as well as some RGB pixels. First question: which of the following ways can help to identify the author of a book? So let me get my pen. So this is from author stylometry section, and the correct answer, this is multiple choice correct, is B, uniqueness of writing, and C, average word length. Now this is on networks package, networks library. Networks in Python is used for making networks, analyzing networks, visualizing networks, or breaking networks. So again, this is multiple choice correct type question. The answer is A, B, and C. Moving on, what is the output of the following program? So we have a string and then we are trying to print something. So please take a minute to solve this question and then we will discuss the answer. Okay, so let us now look at the answer. The correct option is option C. So this list function basically converts this string into a list of characters. So what this does is, it converts the given string to a list of characters. including the space. So you see here we have this space. So the difference between B and C, option B and option C, is that space is missing in option B, so that's why it is incorrect. And option C is correct. It includes the space as well. So let us try and run this in Python and verify it for ourselves. So let us try running this code snippet in Python. So we have the string, and then we will print list of s. Let's see. See, this list is coming in which every element is the character of this string, including this space. So see, every character is there. JOC space PYTHON. So this list converts this string into a list of all the characters. So let's get back. Okay, so moving forward. In the world, on average, how many hops will it take to connect two people? So this was one of the problems we discussed when we were discussing networks and graphs. How two people can be related? So you can see that, for example, if I have 10 friends and each of my friends has 10 to 15 friends, then that way you can two people can be connected in these number of steps or number of hops. So for example, let me just say, let's say person A has 3 friends. Okay, not A, let me call A naught. So person A naught has 3 friends, B1, B2 and B3. And let's say B1 also has B1 has, let's say, 4 friends. So C1, C2, C3. So if I want to move from A naught to C3, if I want to move from A naught to C3, I need two hops. Two hops. First hop will be from A naught to B1 and second hop will be from B1 to C3. So the question is, on an average, how many hops will it take to connect two people? The best case scenario would be one hop. So me and my friend, we are connected by one hop, and so we need to find out. And the worst possible scenario could be like as many number of people that are there. So but we need to we need to tell on an average how many hops will it take to connect two people. So take a few seconds to answer this. Okay, so the correct answer is option A, 6. On an average, it takes 6 hops to connect two people in the world. Next question on networks. In the following code, nx.is connected G will return what? We need to select true, false, or sometimes true, sometimes false. So we are importing the networks package and then we are generating some graph. random graph, and we need to tell whether this will be a connected graph or not. So is connected command uh, returns true if the graph is connected, and false if the graph is not connected. And connected means that each node has at least one edge. So there are no free nodes hanging here and there. So connected graph means each node has at least one edge. So let's say if I want to draw a connected graph, so I have one node, this, and like this. So this is a connected graph. And a not connected graph would be something like this. It will have some free nodes. So let's say this node is connected, but this is a free node. So take about a minute to answer this. Okay, so the correct answer is it will return true. Now you might be thinking that this is generating a random graph, so it should be sometimes true, sometimes false. But look at the arguments to this random graph. First argument tells you the number of nodes, and the second argument tells you probability of having an edge connected to the node. So that probability is equal to 1 in this case. That means every node will definitely have an edge. And since every node will definitely have an edge, then that means it is a connected graph. So if it is a connected graph, then is connected will return true in that case. Had this probability been less than 1, then option C would have been correct. Okay, so if this, instead of 1, if we had written 0.5, then option C would have been correct. Okay, so let me get rid of this, and we need to import the networks library first. Import networks as nx, and then g is equal to nx dot gnp underscore random graph, random underscore graph, and we have 5 nodes with probability 1 for the edge, and then we have to print nx dot is connected g. Okay, so that's all. Let's run it. True. See, it is true, and let us run it multiple times and see, every time the output is true. As mentioned, as I explained, that this is probability is 1, so as a result it will be true all the time. See, every time I'm running, the output is true. Next question on graphs. So how many neighbors does node 4 have? Again, take some time to answer this question before we discuss it. So let us now look at this. So node 4, where is node 4? So this is node 4, and neighbors means how many other nodes are connected to it. So you see that here there is one connection and here there is one connection. So there are 2 neighbors, and these neighbors are nodes 1 and 3. Moving on. While calculating the area of a state, how can we increase the accuracy of the calculated area? So we discussed in this week one method of figuring out the area of a region. So let's say we have a region and we have an area within this region, and what we do is we randomly place dots. So here is an area within the region, and we will randomly place dots in this entire region. Randomly I am trying to place the dots, and then the area of the purple region divided by area of the blue region is equal to number of dots in purple region divided by number of dots in blue region. So if we know the area of the blue region, then we can find out the area of this purple region by simply multiplying this ratio with the area of the blue region. So this is one way in which we can find out areas of regions, and this was what was discussed in this week. So now the question is, how do we increase the accuracy of the calculated area. Take a few seconds to answer. Okay, so the correct answer is by increasing the number of points. Option B. So more the number of points, more will be the accuracy. Moving on. How many nodes and edges does the following graph have? So the options are such that it's written node, number of nodes, comma, number of edges. So what we have is this blue circle is basically a node and this black line is an edge. So we can clearly see we have 5 such blue dots, so 5 nodes, and 2 such black lines, so 2 edges. 5 comma 2, that means option C. Moving on. Which function of NLTK is used to make a frequency distribution of words? So NLTK stands for Natural Language Toolkit. And this was used for the author stylometry part. And the question is, how do we make a frequency distribution of words? What is the command? So it's a syntax based question. Just take a few seconds to answer. Okay, so the correct option is frequency, sorry, FREQDIST, freak dist. Option B. Next question. Degree of separation of the following graph is, we need to find out the degree of separation. So the correct answer in this case is option A, 1. Why? Because this is a connected graph. Connected graph meaning every node, every node is connected to every other node. So what it means is we can go from one node to the other in one step. So the number of steps taken from going from one node to the other is known as the degree of separation. Here it is just one step because every node is connected. That's why degree of separation is 1. Next question, again on author stylometry. How can we identify which book is written by which author? So we had seen a similar question in the beginning of this lecture session. The first question of today's class was also on author stylometry. Okay, correct answer is option B, by analyzing word length with previous books. How can a list uh, L be converted into a tuple? So we have a list L, and how do we convert it into a tuple? So what is a tuple? Tuples are fixed data types, data structures. Means they cannot be changed once they are made. Whereas lists can be changed even after they have been created. So the correct answer is A, tuple L converts. So this tuple function converts the input list to an output tuple. Next question is on networks and graphs. So will the following piece of code always return true? So note that it is asking whether it will always return true or not. So again we have we are generating a random graph, and then we want to know whether it is connected or not. So we had seen a similar question earlier. Let me go back to that question. Yeah, here question number 5. So as we had seen that is connected is a function which returns true if the graph is connected, and random graph is a nx.gnp underscore random underscore graph is a function which takes two arguments, node and the probability. So first argument is number of nodes, second argument is probability of having an edge from that node. So since we have seen a similar question, please try to answer this. I expect that now everybody will get the right answer because we have already discussed this earlier today. So take a few seconds to answer this question. Okay, so the correct answer is obviously this for this case it is false. Why false? Because uh, so we have 10 number of nodes and the probability is 0.5, probability of having an edge from a node, and this probability is less than 1, which means that there can be times wherein means when a node is not connected, when it is not connected to any other node. There is 50% chance that a node will not be connected to another node because the probability of edge is zero point 0.5. So as a result, sometimes you might get true, sometimes you might get false, but the question is whether it will always return true, and that for that case it is false. It will not always return true. It might return true sometimes, it might return false sometimes, but not always. So if the probability is 1, then it will always return true, because then it will always be a connected graph. Each node will always have at least one edge. If the probability is 0, then it will always return false because none of the nodes will be connected. So it will not be a connected graph. But if it is in between 0 and 1, then it will return true sometimes and it will return false sometimes. Let us try and run this in Python. Okay, so this code is similar to the previous code that we had written. So I just need to change these nodes and the probability. So let me just check what is the probability. So yes, probability is given as 0.5. So let us run this. See right now, true, 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 false. See, after 4 times true, it became false. True, 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 true. Right now it's all coming true. I don't know why false is not coming at all. But once we had seen false, right? So even if we get false once, that is enough to say that it will not always return true. Okay, let me put this thing inside a loop. Right now all is coming true. Why? What happened? I don't understand. Oh, my computer is... Just give me a minute. I think it is not executing. Let me just clear this console. True, 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 So only once I had seen false. I showed you once false. After that it is all true, true. Let us reduce this probability further. Now see false, false, true, false, false, false. Oh, again hang. So let's do one thing. Let's run this in a loop. Let's run this 20 times. And let's draw it as well. Or let me draw later, but first let us print. Oh, all false. Let's increase probability a little bit. See, some true, some false, some true, some false. Mostly true, some false. So 0.5 is also, it seems quite high a probability with such less number of nodes. Let's say if I increase the number of nodes. So all true it is showing. 50 times. Let's run this. Okay, only once I had seen false. After that it is all showing true, 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 true. Anyway, even if once we see false, see false here once. See, so many times it is true, but once it is false. So even if it is false for once, that means always true will not be given as the output. See here, false. Amongst so many true, there is one false. Okay, so let us get back. Oh, before that, let me draw the graph. Let me show you how to draw this graph. So let's draw. See, this is the graph that we are getting. And since it is random, next time we get the graph, it will be different. See, next time, oh, it is coming on top of it. So let me see, a different looking graph is there. So wait, let me do one thing. Let me show you all the graphs side by side. Okay, now let me run. See, this is one graph, and if I run again, see, these two graphs are different because it is random graph, so it will be different. And if I reduce the probability slightly, see, this node is not connected, so is connected is false. See, these two nodes not connected, that's why is connected is false. See, all the nodes are connected, that's why it is connected is giving true. Okay, so I hope now uh, this function is clear, is connected function. Okay, coming back. What is the output of the following code? So again, this is on networks. So we are importing the networks library. Then we are generating a graph from the nx.graph command. We are initializing a blank graph. Then we are adding nodes and then we are adding edges. And finally, once you have added the nodes and the edges, we are plotting the graph. So we need to select what is the correct output or the correct output graph given these nodes and edges. So take about a minute to solve. Okay, so let us now discuss. So the correct answer is option D, and let us see why this is correct. So we have four nodes. We have four nodes called 1 2 3 4, and then we have 1 2 3 4 5 6 edges. So 6 edges are there. Sorry, 1 2 3. Oh, there are 6 elements, but number of edges are only 5 edges. Why? Because 1 comma 2 and 2 comma 1, they are the same. These two are essentially the same. Whether 1 is connected to 2 or 2 is connected to 1, it doesn't make any difference. So there are 5 unique edges. So immediately you see that option A and option B are ruled out because option A has 3 edges and option B has 2 edges. And even option C is ruled out because it has 4 edges. So only option D is correct. It has 5 edges. And if you look at it, then the correct edges are there. So let us see what are the edges. So let us look at the connections from 1. So 1 is connected to 2. This is the same. 1 is connected to 4 and 1 is connected to 3. So this is my node 1. It is connected to 2. Very good. To it is then connected to 4 also. This is 4 and it is also connected to 3. So that's good. Then we have connections from the node 3. So 3 is connected to 2, 3 is connected to 4. So this is the node 3. Also 3 is also connected to 1. So 3 is connected to 1. That's good. 3 is connected to 2 and 3 is connected to 4. So we have the proper nodes and the proper connections. Again, let us try and test this out in Python as well. The next question is also on networks. So G equals nx dot graph. Then we want to add nodes. G dot add nodes from, and then we have this list 1, 2, 3, and 4. Then we want to add edges, and then we will add 1, 2, 2, 1, 2, 3, 3, 4, 4, 1, and 3, 1. Then we want to draw it, and we also want to put the labels for the nodes, and finally plt dot show. See, this is the kind of graph that is coming, and this is what we had selected. So the graph that is there in the options is just the mirror image of this. It's just flipped upside down, but the connections and the naming of the nodes, they are the same. Shape is same, it's just flipped upside down, and that is not a problem. See, now it is showing flipped, again some flipped version, but what is important is naming of the nodes and the connections. See, all of these are same, so they might look different to you, but they are essentially all the same graph. That's why I'm just running it a few times to show you that all of these are indeed the same graph. See, this is now the exact same shape that we have in the question as the options. So what is important is naming of the nodes and the connections. Okay, so let's get back. Okay, moving forward. How many edges are there in the following graph? So by now you know what a node means and what an edge means. So please try and count the number of edges in this graph. Okay, so this is very easy. The correct option is option 4. Oh, sorry, I need to change the color of my pen. The correct option is option 4. So this graph has 4 nodes and 4 edges. So if we count the edges, we see this is one edge, this is another edge, edge number 2, then this is the third edge, and this is the fourth edge. So we have 4 edges and then we have 4 nodes. So node 1, node 2, node 3, and then node 4. Great. Moving on. How many neighbors does node 3 have? So take a few seconds to answer this. Okay, so let us look at the node 3. So this is node 3, and if we look at the connections to node 3, so this is one edge, this is another edge, this is the third edge. So we see that there are three connections, so it has three neighbors, and the neighbors are 2, 1 and 4 nodes. So that means the correct option is option D. It has 3 neighbors. Next question. In which of the following ways can we create a string in Python? By single quotes, double quotes, triple quotes, or all of the above? So you have seen how we use strings, and we use quotes to initialize strings. But how many quotes can we use? You need to select. Okay, so the correct option is all of the above. You can use single, double, as well as triple quotes. But the key is that you have to be consistent. Meaning, if you have a string S, let's say you want to use single quotes, then you have to close it also with a single quote. Okay, this is correct. You can again you also you can have open with double quote, close with double quote. This is correct. Open with triple quotes, close with triple quotes. This is also correct. But you can't do something like open with a single quote and then close with a double quote. This is incorrect. So if you open with a single quote, you have to close with a single quote. If you open with double, you have to close with double. You can't open with, let's say, triple and close with only single. That is not allowed. So consistency in using the quotes is important. Next question. How many nodes edges does the following graph have? So this is also similar to one of the previous questions we had seen. Where was it? Yeah, here, where we had to count the number of nodes and number of edges. So similar question is there, but for a different graph. So I believe all of you would get it right. So please count the total number of nodes and total number of edges. Okay, so let us count it. Let us first count the number of nodes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, wait, somewhere I'm doing some counting wrong. Sorry. This is the 8th node, this is the ninth node, and this is the 10th node. And then let us count the number of edges. So we have one edge. So green is for nodes, purple is counting edges, one edge. Then we have edge number 2, edge number 3, edge number 4, edge number 5, and edge number 6. So we have 10 nodes and 6 edges. So option A is the correct option. A complete graph will have a degree of separation. We need to select the correct option, and we had a similar question on degree of separation earlier as well, where we had this kind of a graph, and now we need to tell what is the degree of separation for a complete graph. Again, I had discussed this answer today itself earlier in this session, so I believe all of you know the answer. So please take a few seconds to answer. Okay, so the correct option is option 1. A complete graph will have a degree of separation 1. So what is a complete graph? A complete graph is a graph in which every node is connected to, so basically each node is connected to every other node. This is a connected graph. So in that case, it will have a degree of separation 1. Why? Because from one node to another node, you can go in exactly one step. So the previous question that we had, which was similar, so this question number 10, this was also similar. Here also, this is a connected graph. Why this is a connected graph? Because every node is connected to every other node. You can see that each node is connected to the other remaining nodes. And as a result, the degree of separation is 1, because you can go from one node to the other in exactly one step. Okay, last question from the MCQ type assignment questions. It's a syntax based question. How can we get the RGB value of a pixel? So syntax based question, there is nothing much to think about it over here. So let me just tell you the correct answer. The correct answer is option B. Get pixel command gives you the RGB for a given pixel. So the syntax for using this get pixel function is like as follows. So first we need to open an image. So for that we will use the PIL library. Then we will open the corresponding image that we want, whatever is the name of that image. We will open that, and then to get the RGB you can print im.getPixel, and then the coordinate would be x and y. So get pixel x coordinate, y coordinate, whatever the x coordinate, you have to initialize it somewhere. You have to initialize your x comma y coordinate, then it will tell you the RGB for that particular pixel coordinate. So this is the syntax of using get pixel. So this completes the MCQ type questions. Now we will move to the programming aspect, the programming assignment questions. So this is the first question in the programming assignment. So we are given two strings s1 and s2, and we are supposed to write a function called substr which accepts two parameters s1 and s2 and returns true if s2 is a substring of s1, otherwise it returns false. What is a substring? So a substring is a continuous sequence of characters within a string. So we have some examples. So if the input is banana mania, that's the first string, and if the second string is nana, then we see that the output will be true. Why? Let me highlight the corresponding sections. So if you look in this region, you see that string 2 is indeed a substring of string 1. This is the common part which I have highlighted. In the second example, the output is false because the second string is not a substring of the first one. So we need to write the code for it. So let us first write it with a pen and paper. So we have to define the function. Let us define the function called substr. It takes two inputs, s1 and s2. So we will find out the length of the strings. len is the command for finding the length of the string. So we will scan the strings. Break command is used to come out of the loop. So this is the function, and then let us take input for the first string, input for the second string, and then we will print the output. Okay, so what is happening over here is we are running a for loop for m minus n plus 1. That means m minus n is basically the uh, region, the unique region. So you see that there will be some common part. So string 1 is there, which is a bigger string, longer string. So s1 is longer, so its length will be having a bigger value. S2 is the shorter string. So longer minus shorter, that dimension we want to scan. So that's the first for loop. And then in the second for loop, we are actually scanning and trying to see whether the sequence of the string S2 is present in string S1 or not. And if the sequence is not there, then we break out of the loop and we return false. So let us now write it in Python and see. So let us write the code for this programming assignment. Let me remove all of this. So we have the function, I'm just writing the code. Break command is used to get out of the loop. So this is the code, I'm running it. Let me input the strings. So first let us write the example strings. Banana mania, first string, and then the second string is Nana. Oh, sorry, I wrote banana mania, not banana mania. Let me run again. So that's why it is giving false, because Nana is not a substring of banana mania. So let me write properly, banana mania. Yes, now it's correct. Now Nana, now it returns true, so it is correct. Let us try the other example string, A B B C C, and then A B C. So it returns false. So this code is working fine. Moving to the next question. Given two dictionaries D1 and D2, write a function merge dic that accepts two dictionaries D1 and D2 and returns a new dictionary by merging D1 and D2. Okay, I forgot to write D over here, merging D1 and D2. And what is important that the contents of D1 should appear before the contents of D2 in the new dictionary and in the same order. And when we have duplicate values, then we will retain the value present in the first dictionary, that is D1. So here is the input, example input. So we have two dictionaries, they have distinct elements, and finally we have the combined merged dictionary in which the sequence or the order of the dictionaries is of the elements in the dictionaries are preserved. So let us now write the program. Let's define the function. So first we will scan the first dictionary and add it in the new merged dictionary D3. Then we will scan the second dictionary and we will add only the non-duplicate items. So that is the function definition. Then we will take input keys in the form of a list. Values also. So let me just copy paste this thing once again. And then we will assign these keys and values to this D1 dictionary. So this len command is used to find the length of lists. Then we will take input for D2 also. Let me copy once again. Oh sorry, I'm not able to copy it. Okay, now I got it. Copy and then paste it. Oh, I'm running out of space, it seems. Let me move everything a little bit. Oh, this is becoming difficult to copy things. Got it. Let's move it a little bit higher up, and let me reduce the size a little bit. Yes, now I think I have some space. Okay, done. And I need to change. This time it is not D1 but D2. Oh, we need to print the output. So after this you will print the output, which is merge dic D1 comma D2. Note that I have used semicolon over here. Okay, so in Python each new line is taken as a new statement. So if you write things in new lines, it is a new statement. But if you write things in one line, Python reads it as one statement. So if you want to write two statements in one line, you have to separate them by a semicolon. So let me just write it once again. So we can have statement 1 to execute, and then statement 2 to execute. So this is perfectly fine, it will execute. Or we can have statement 1 means whatever that thing is, semicolon statement 2. This syntax is also correct, but if you simply write statement 1 without any semicolon, just if you put a space, and if you write statement 2, then this is wrong. This will give you an error. So let us run this in Python. Next question is on dictionaries. So let's remove this. Merge dic. So duplicate items should not be repeated. That's why we have this if condition. Now we will take input from the user. And let me copy this for value as well. Now we will initialize the dictionary and assign it the keys and values that we took as input from the user. Now for the second dictionary as well. Let's copy this. Okay, so this is done, and then we have to print. Oh, sorry, val is not defined, it is value, or rather, let me keep this as val. Okay, now everything is fine. Let us run this. Okay, so let me first enter the keys 1 and 2 for the first string, and then the first dictionary, then the values also 1 and 2. That's the first dictionary. Now for the second dictionary, value keys will be 3 and 4, values also 3 and 4. So see, the output is there as expected. So we had seen this example input and output. Now let us do some random test case. So for first dictionary, let me say the keys are 1, 2 and 3, and let the values be 0, 10, 5. For the second dictionary, let the keys be 2, 4, 8, and let the values be 1, 2 and 3. So see, now two keys are repeated, 2 and 2 in this. So that repeated value, duplicate value should not be repeated. See, correct. 1, 2, 3, 4 and 8. All the unique key IDs are there with the corresponding key values. One has 0, 2 is having 1. It is taking from this second one. Then 3 has 5, 4 has 2, 8 has 3. Okay. So if we want to retain the value from the first dictionary, then we can modify this code a little bit over here. Let's keep this key 1 value 1. So let me run this code once again. So right now it is taking value from the second one for the duplicate case, and I want to make it such that the value is taken from the first one. I don't understand why it is taking the second one actually. So I'm taking the first dictionary and I'm assigning these keys and values. Okay, let me print over here, print D3 and see what is happening. Let me have an else command here and say continue. Still it is taking the second key value. Okay, let me print D1 and D2 as well. Oh, sorry, not d3.items. This should be d3.keys. This is the error that I have made. This is wrong. See, items is what? Items will give you keys and values both. So here was the error that I was making. Let me write it down. So items gives you key and value both, whereas key gives you only key. So we want to check only for the key, not for the value. Now this will run correctly. So 1 2 3 0 1 5 2 4 8 4 8 6. See, now it is retaining key from the first one. So let's remove these extra print statements, so they are not required anymore. So let me just comment them out. And then let us run it again. Okay, so let us give the key values for the first dictionary 1 2 and 3. then the values, then for the second dictionary keys and the values. And see, now it is giving the correct merged dictionary. So key 2 is repeated and it is retaining the value for key 2 from the first dictionary, that is 1, instead of from the second dictionary. So now this is working perfectly fine. Just one more example, let us try. So again we have a duplicate key and it is retaining the key value for the duplicate key from the first dictionary, which is what we wanted. So now this code is working perfectly fine. So we had to keep d3.keys, that was the error. Now it is fine. Okay, great. Moving on. So this is the last question for today. Given an integer n, print all the indices of numbers in that integer from left to right. So we have input equal to 1, 2, 2, 3, 4, 5, and output is the digit and its corresponding index. So the index for the first digit 1 is 0 because in Python indexing starts from 0. Then the next digit is 2 and 2 is present at two locations, at index 1 as well as at index 2. Then we have digit 3 which is at index 3, then digit 4 at index 4, and finally digit 5 at index 5. So let us write the code for it. So we'll take an integer input. So by default Python input is a string, so you need to convert it into an integer by the int command. Or let it be a string only, then that way indexing will become easier. Then let us have the dictionary. We are adding a key to the dictionary. And then we will print it. Okay, so this is the code. Let us try and run it in Python. So coming back, this brings us to the end of this live programming problem solving session for this week, that is week 9. And I hope this session was helpful to all of you. We meet next Saturday for week 10 at 3 p.m. So this is 2-hour live session, 3 p.m. to 5 p.m. every Saturday, and we discuss problems from that week, that particular week which is running. So this was for week 9, and I hope now you have a little bit better understanding of the concepts discussed in this week, particularly networks. Okay, so thank you very much. See you next week. So this is the last programming question for today, and let me remove this previous code. Let's get rid of all of this. So this is the code for finding out the indices of the digits in a given number. So we will have a given number. We will take it as input. I will let this this should be an integer input, but I will let it be a string. Then we will have a dictionary, and then we will write a for loop for updating the keys and values in this dictionary. So the keys would basically be the digits, and the values would be the indices where those digits occur. So let me just write down the code. I am just copying the code from the lecture notes that we just saw. And now that we have the values and keys, we will print them. So we need to print it to show the output. So d.items gives both keys and values, and d.keys gives only keys. One needs to be careful when using these two commands. Okay, so the code is written, and let us test our code by running it. So let me give the example input 1, 2, 2, 3, 4, 5. Oh, there is some error. It says int object has no attribute append. Okay, but I am taking it as a string. So where is the error? Okay, let's check. Okay, let's do one thing. Let me try and convert this to an integer and then convert it back into a string. So I'll take the input, I will convert it into an integer, and then we will see what happens. Yeah, so let's convert it into an integer and then a string, and then let's run it. Again, let me put the example input. Oh, still the same error. So let us try to debug this code, and for that let us try to put some extra print statements at each line and see what is happening. So let's print n at each step. Okay, let's print the type also. Type the in number n as well as its type. Okay, so it is becoming a string. Still it is showing the error. So I've converted it into a string, and still it is showing int has no attribute append. Okay, let's check once again. Oh, so line number 14 is the problem. This should be inside square brackets to convert it into a string. Yeah, now see, this is working perfectly fine. So 1, 2, 2, 3, 4, 5. Digit 1 is at index 0. 2 is at 1 and 2. So it's working fine. So let us get rid of all the extra stuff that we had put in for debugging. All these extra print statements. Let's comment it out and let's run it. So 1, 2, 2, 3, 4, 5. Yeah, perfect. So digit 1 at index 0, 2 at 1 and 2, 3 at 3, 4 at 4, 5 at 5. So let's clean up our code now, since everything is working fine. So the main idea was in line 14, that was the error. So that I had to be inside square brackets. So yeah, now this is a nice clean code. Let's run it once again. Great. So we are getting the correct answer as we had expected from the example case. We are getting the digits and its corresponding indices where they occur in the integer. So let's run it once again for some different number. 101254. Let's run it. Great. So digit 1 is at index 0 as well as 2, because this is 101, this number. So 1 is at index 0 and 2, 0 at 1, 2 at 3, 5 at 4 and 4 at index 5. So this piece of code is working perfectly fine. Again, I want to reiterate, the main idea was in line 12, so that I had to be inside square brackets to convert it to a string or a list. Otherwise, to convert it to a list. Otherwise, it was integer.